Guys, today we are going to do variable compositions, and it's basically the same thing that we did with our trig compositions. It's just now they've put letters in instead of numbers, just like math is wanting to do. So the first thing that we are always going to do with something with a trig function is we're going to draw a triangle. So for this first one, number 1, it says sine of the inverse cosine of x. Remember, this is looking for an angle, so I'm going to be labeling my sides on this guy. So I'm going to draw myself a triangle, and this will be my theta. I'm just going to orient myself like a reference angle, and I know cosine is going to be my adjacent over my hypotenuse. So remember, if there's nothing under there, it's a 1, so my adjacent side is x, my hypotenuse is 1. Now what I have to do is I'm going to have to go through and find my missing side. So to find my missing side length, this is just going to be the Pythagorean theorem again. A squared plus b squared is equal to c squared. So I would have this one, I'll just call this a. So I'd have a squared plus x squared is equal to 1 squared. So the biggest thing here is, remember, I'm trying to solve this for a, not for x. I'm going to leave x in my answer. So I'm going to subtract x squared from both sides. So 1 squared is 1 minus x squared. Then I'm going to take the square root of both sides. So I know that this other side over here is going to be equivalent to 1 minus x squared. And I'm just going to leave it like that. I cannot take the square root of 1 minus x squared because it's all in parentheses and there's nothing times itself that's going to give me this particular thing. So I'm just going to leave it alone and leave it underneath the square root. Now that I have all three sides of my triangles labeled, I'm going to find my new trig value. So for this one, it's sine. So if I was looking for my sine of theta is going to be your opposite over your hypotenuse. And we just found that opposite side. It was the square root of 1 minus x squared. And then my hypotenuse was just 1. So I could just write my answer as the square root of 1 minus x squared. So that's all we're really doing here. We're drawing a triangle, we're finding the last side, and then we're using our SOHCAHTOA in order to find the new stuff. Okay, so if I look at something like this, we have the cosine of the inverse tangent of x. Again, first step, I need to draw my triangle. I'm going to put my reference angle, again, just down in the bottom. It's not really a big deal where you put it as long as you label your triangle correctly. Tangent is opposite over adjacent, and again, I'm over 1 here. So my opposite side is x, my adjacent side is 1, and I need to now find this last side. And I'm going to call this one c because it is in fact the hypotenuse. So I'm going to have leg squared, 1 squared, plus the other leg squared, x squared, equal to c squared. And again, I'm trying to solve for c, not x. So this one's really nice. I can just take the square root of both sides. And I know that c would be equivalent to 1 squared is 1, plus x squared equals that value. So I know that the hypotenuse is 1 plus x squared. So now if I'm looking for my cosine of that angle, it would be my adjacent side over my hypotenuse. So I'd have 1 over the square root of 1 plus x squared. And we do not have to rationalize my denominator, otherwise that would be scary. Okay, and so that would be my final answer. Kind of gross, has an x in it, oh well. Okay, so then I'm going to look at something like this. We have the secant of the inverse tangent of 3x. So my first step, always draw my triangle. Theta, right angle. And I know that tangent is my opposite over my adjacent. And remember, there's that invisible 1 under there. So I have 3x and then 1. Now I'm going to find that missing side. And again, it's the hypotenuse, so it's c. So I'm going to have a squared plus b squared equals c squared. Now be really careful. If you notice right here, I put in some parentheses because you have to square the entire 3x. This isn't just 3x squared. This is 3x times 3x. So for your answer here, you'd have 1 plus 3x times 3x is 9x squared is equal to c squared. So be so careful. If you have something that has like a coefficient in the front, you have to square the coefficient and you have to square the letter. So now at this point, this one's nice again. I can just take the square root of both sides, and I know that my hypotenuse would be equal to 1 plus 9x squared. And then I'm going to go ahead and find my secant of theta. So my secant value is going to be the reciprocal of cosine. So we'd have hypotenuse over adjacent. So my hypotenuse was that square root thing, 1 plus square root of 1 plus 9x squared. All over my adjacent side was 1. So again, I can kind of ignore my denominator if it's a 1. And last but not least, example number 4. Again, we're going to draw our triangle. Since a pattern here, just always draw a triangle. You know that your cosine is going to be your adjacent over your hypotenuse using SOHCAHTOA. So my adjacent side is x, my hypotenuse is 3. And then I'm going to go ahead and use the Pythagorean theorem to figure out what this side is. And again, I'm going to call it a. It's not the hypotenuse, so I'm going to call it either a or b. So I'd have a squared plus x squared equals to 3 squared. Remember, we're solving for a here. So I'd have a squared is equal to 9 minus x squared, because I need to subtract x squared from both sides. Take the square root, and I would find that my last side would be 9 square root of 9 minus x squared. So a is equal to square root of 9 minus x squared. So finally, my last step here, my tangent of this triangle, the tangent of this angle would be my opposite over my adjacent, TOA. So my opposite here was that crazy thing, square root of 9 minus x squared. All over my adjacent side is x, and again, leave that like it is. And that's all there is to variable compositions.